All right, so we're back to what we did yesterday. You should have this all filled out until force of gravity. So the whole top half should be filled out. So I want to do a quick review, and I want to put at the top here. Yep. That pen's dead. I actually really like using up pens because I never actually used one up. Eccentricity of a circle. Guys, what's the eccentricity of a circle? Check through the notes. No, I'm asking what is the number value for the, what do you got, Sean? 0 equals 0. ECC. ENTRI city. What's the highest eccentricity you can have? Don't just say words, would you? You weren't even here. No. Highest eccentricity you can have is 1. So an eccentricity, when you calculate eccentricity, your answer will be between 0 and 1 always. If you ever get a number bigger than 1, you screwed up. So that's your first kicker. And then the other thing about eccentricity that you have to remember is if the number is closer to 0, what shape is it? Closer to 0, what shape is it? More of a circle. So the smaller the number, the more round. So we're gonna do some more practice with eccentricity, but before we get there, eccentricity does end up affecting gravity. So what we got to do is fill in the rest of those notes at the bottom first before we practice. You guys know what gravity is? What? It depends on the day you know what gravity is. Are you serious? Guys, what does gravity do? Sean? Pulls things down, pulls things towards them. It is an invisible force of attraction. So that goes right where it says number 1, gravity. It's an invisible force of attraction. Everything has some gravity. Even you. How come I'm not being pulled towards Mrs. Jones right now? Because Mrs. Jones does not have enough mass to pull me towards her. What does have enough mass to pull me towards her? The earth. So everything has its own gravity, but some of it, we can't feel it because it's too strong because you're not big enough.
Oh, you're making me think a lot right now.
Renee, how's the head? Are we okay so far?
Right now, I'm thinking, what if nothing ever happened? What if Earth was never real?
Hey, you're gonna mess with Renee. Stop talking. Stop. This is the kind of stuff that keeps you awake at night. All right. So everything has its own gravity, even you. Even the moon. So the moon has its own gravity. How come I'm not being pulled towards the moon right now?
You actually reincarnate
Together now. Because the moon doesn't have enough mass. But next week. Okay. So the moon does have its own gravity, but the moon's not big enough to pull it toward this. So what is a really big thing around? A really big object. The sun. Remember, the sun was like 330. Well, I know right here. 333,000 Earths. How come, if size affects the gravity, how come we are not being pulled towards, how come we're being pulled towards the Earth? And I am not being shot through the sky towards the sun right now. Okay, so there's gravity, but why? What I'm asking is, why is that gravity pulling us down stronger than the sun's gravity? Because we're closer to it. There are two things that gravity depends on, and they are mass, so size, and distance, how close or far away you are. So that goes in the second blank there that says gravity depends on two things, mass and distance. And then the next blank says the larger the mass, the blank, the gravitational attraction. The larger the mass, the larger, greater, stronger, any of those words. Greater is the one I use. And then the same, the closer the objects are together, again, the greater the attraction. So two graters there in those blanks. Again, I think I left off something, a blank that would make this better here. At the very top of the next plate, up here, I would like you to write stronger. Well, I'm not actually sure what I want to write. Gravitational attraction makes planets, oh shoot, move faster. Wow, that is the messiest handwriting I've ever done. Stronger gravitational attraction makes planets move faster. Why is this important? So what shape does the Earth go around the sun? What, say it again? An oval. And where is the sun when the Earth is going around the sun? One of the foci, but remember, an oval doesn't have a dead smack center. So here's an example here. There's the sun. Here's the path the Earth takes around the sun. Does that need a label? Sun. When the Earth is going around the sun in this shape, is the Earth always the same distance from the sun? Nope. Because it's an oval, sometimes, like when it's over here by C and D, the Earth is much closer to the sun than when it's over here by A and B. So what do we know about the gravitational attraction at C and D compared to A and B? Okay, remember, when it's closer, stronger. So here there's more gravity here than there is there. And because of what we just said, the stronger the gravitational attraction, the faster it will move. So weird enough, when the Earth is over here by C and D, it's moving faster than when it's over here by A and B. Interesting, huh? So what we need here, it says between which two letters is the orbital speed moving the slowest? Take a second to figure that one out. Look at the picture. Between what two letters is it moving the slowest? What are we looking for? We got Riley. Better? Yeah, that's all I need is you guys tell me that because it only depends on where you're sitting and how much you can hear them. You see, you can't hear them, but that was driving you insane, wasn't it? Yeah, you guys just need to say something because not everybody can hear them. So anyway, now that we can focus, my question is, which two letters is it moving the slowest? Two letters, A and B. Why A and B? Because they are farther away. So then which two are they moving the fastest? C and D. Again, why? Not talking to you. Why are they moving this? What are we doing? The fastest between C and D? Closer to what? Yep, closer to the sun. And we're going to actually ignore this whole area covered by because I don't think it matters enough right now. Take your word for it. Okay. I will take your word for it. Wait, here, would you like there? Well, if the other one was a sine, that one would be a cosine wave. Anyway, two vocab words we need to use. Now, of course, we can't just use the phrase when it's close to the sun and when it's far away. We have to throw in some vocab words that just are words you've never heard before. They do. We've got one. This was right out of lab. Perihelion, which just means closest to the sun, and aphelion means farthest from the sun. I tell these two apart because when you live with your parents, so perihelion, parents, you're close to your parents. And if you live in an apartment, aphelion, you're far away from your parents. I know it's kind of a stretch to remember how to remember those. If you have a better way of remembering them, let me know because I'm always open for suggestions. But perihelion, you're close to your parents. Aphelion, you live in your own apartment and you're far away from your parents. Or A away, that's the other way. I don't know why I didn't ever say that before. A is away. You can send those waves a little faster next time, would you? I saw it. I saw you wanted to say something and he just chose not to. Do not toss. Let's put it away. A away. A away. Have I never said that before? In 14 years, have I never said that before? Anyway, so that is all the new stuff I wanted to do. As you can see, there's a lot of practice to do. And I did ask you guys to get your own ruler. We are going to spend the next 20 minutes practicing with this stuff. And there are 16 questions in the packet. And by the way, if you don't finish these in class, they will be homework. But you have 20 minutes. I'm pretty sure you're going to get darn near done with them. So what page is this? 16 through 19. 16 questions to do right now. I also got you guys a present.
No,
too.
no way.
I did. No, just in case you don't have your own ruler at home. Got you one. Got your back feet.
I got one.
I have So right now, I want you guys to, should we do one together? Let's double check, make sure we're good at this. Hey, nope. We're moving on. So I heard some voting to do one together. So it starts with base your answers to questions 1 and 2 on the diagram of the ellipse below. First, it says to calculate the eccentricity to the nearest thousandth. So let's see if we can remember the formula for eccentricity. And if you don't remember it, don't bother memorizing it because it's on the front page of your reference table. What is it? Eccentricity equals?
D over L.
Yep, so I do abbreviate it D over L. It's distance between two foci divided by the length of the major axis. Do you have to write this? No, you do not. I would recommend at least writing E equals D over L. So then we got to plug in some numbers for this. So the distance between the two foci, how do I measure that? With a ruler, centimeters. And where are the foci? F1 and F2.
3.0.
No.
2.9.
Mine is definitely 2.8.
2.8.
If you had 2.9, that's fine too. Length of the major axis, what would you describe that as? Like, where does the ruler go?
Anthony, shut up.
What'd you say, Shelby? The edge, from one edge to the other edge. Now be careful. I think this was this your problem yesterday? You measured in the wrong spot. Was that you? Remember, you're going through the equator part. So not down below these little marks, but you're going to want to line the flat part of your ruler with the flat part of those crosses. Mine looks like right on 8.4, but again, if you had 8.3, you go with what you had. And like I said, go ahead and plug that into your calculator. Ooh, this works out perfect. That's the number I got. Now, guys, it said to round to the nearest thousandth. So first of all, what number, how many out is 1,000? 3. So what's my answer? My answer is 0.333. Do I do that little line over the top?
No, you don't.
What does the little line tell you? It means it keeps going. So does that mean you rounded if you put the little line? No, it didn't round, because by putting the line, it's implying it goes on forever. And we don't want this to go on forever. We want it to end at 0.3 or 3.3. Sorry. All right, now the second part of this question says, state how this eccentricity of this ellipse compares to the eccentricity orbit of Mars. Now, how many of you know how oval Mars is?
I don't know.
I don't know, but our ESRT tells us. I think I told you we were going to get to this column next week. I lied, we got to it on Friday. It's on page 15 of your reference table. We got to it today. The orb eccentricity according to the reference table of Mars is, we got 0.093. Does everybody see where that came from? I'm going to show you. Here's page 15. Here's Mars. Go over to the column labeled eccentricity. 0.093. Ours was 0.333. Who has a bigger eccentricity? So we got to practice our wording. It says compare the eccentricity. See how the eccentricity of this ellipse compares to the eccentricity of orbit of Mars. How do we answer this? Now, I would start with a complete thought. This ellipse, yes, by the way. And by this ellipse, I mean this one. Is it more or less or more or less eccentric is more than Mars. Now I have a second question. Which one's more oval? What's the eccentricity of a perfect circle? 0. What's the biggest eccentricity I can have? 1. So which one's more oval? So 2 of you are sticking with Mars. What's
The answer's obviously the other one,
but why? Here's Mars.
all right, so if it's closer to 0, that means it's more of a circle. 0.093 is closer to 0 than,
I said which one's more oval?
yeah, and,
Oh, then it's the other one.
oh.
Because it's
all right,
whatever one is more.
Or this
all right, shucks,
ellipse.
I really-
is more oval. Mars is more round. Not whatevs. You gotta get to know this. How about you guys work on page 17? If you get through 17, there'll be no homework. Please remind me that. You guys are working hard.
Working hard or hardly working?
Get to work. By the way, guys, what are the units on eccentricity?
Nothing.
Nothing. Remember, the centimeters cancel out, and there is no units on eccentricity. Who needs help?
Nope, not one of those.
You don't need help. You do this all the way up on your own. Guys, keep your homemade rulers because I'm gonna make you have homework next week. Oh, nice to know.
I might just take
You
that
guys
over
better
at home.
bring your stuff with you.
Maybe
wherever you're
not,
going.
man.
And tune in to meetings, everything's still required of you.
But she's still mad at you.
I'm not gonna do this.
And then I asked you, but the video will be there, you can watch it. No, you don't need to zoom it. They were all in. When I made them join, they were nice. They were better.
It was only 30 days old.
You take your packet.
Yeah.
Middle hall already? You were in.
Wait, Miss Britt, I thought we were around.
So always what they say. So clearly this one doesn't need you round to the nearest thousand. So round your answer to look like this. Riley had a good point because I've told you guys now that they're going to make you round to the nearest thousandth every time. You'll notice that very first question only rounds to the 10. So just be careful if they tell you to round to the 1,000, do it. If they don't, just go with whatever, it's fine. But if they tell you what to do, do it. Remember to go faster when they're closer.
Okay, so.
So, or. Yeah, so it's going from A to B, C, closer or farther away? Yeah. But hang on. But this is an app, this goes all the way down from A to B. So it's going any farther away.
Really warm. Three times they feel like six. And the fourth one tells the third
So remember, the closer they are to the star or the sun, the faster they go because the gravity's stronger.
Good, okay, so now.
And then that'll affect how fast they go. Closer that, guys, remember, the closer they are to the sun or the star, the faster they go. The closer they are, the stronger the gravity, and then the stronger the gravity, the faster they go. We're gonna go over it. All right, so hopefully you had some time to get these done. Let's go ahead and go over questions 3 through 7. And like I said, I changed it to no homework. I think you guys don't need any. So the first thing you had to do, it says the calculated eccentricity of this orbit is approximately, and it's a multiple choice question. Sometimes people think multiple choice questions, you don't have to do a lot. But you still had to calculate the eccentricity here. So eccentricity is always distance between the two foci divided by the length of the major axis. What did you guys get as the distance between the two of them? Michael says 0.2. You guys all good with that? And what was the length of the major axis? What'd you say? 6.7? Oh. Yeah, Michael. That's not what we're doing. What was the distance? 1.5. And 1.5 divided by 6.7. 1.5 divided by 6.7 gives you 0.222, which is closest to 0.2. Nice job. Now the gravitational attraction, remember, closer to star equals stronger gravity. Thanks. Top thing in that bin right there. Sorry about that earlier. So which one's closest to the star? Should be A, which means A is going to have the strongest gravitational attraction. And then what do we know about speed of the planets? Closer equals faster. So which, I'm not even going to answer the question yet. Which spot is it moving the fastest? A is moving the fastest because it's closest. Which one is it moving the slowest? Which one is it moving the slowest? C, why? Yep, slowest. So we want to know what happens when you go from A to D. So when you go from A to B, what happens? Hello? You go from A to B, you get farther away, so it goes slower. What happens when you go from C to D? I mean, from B to C? Gets even slower. But it wants, so far it's decreasing, but then it goes from C to D. What happens? Starts to increase because it gets faster. It'll be decrease, then increase. They love question 6 because it's really a 2-part question. They give you a diagram and they say this is closest to the eccentricity of what planet? What do you have to do first? What are you going to do in your ESRT first? So you want to look what these eccentricities are first? Mercury has an eccentricity of 2.06. Earth has an eccentricity of 0.017. Saturn has 0.054 and Neptune 0.009. Now what? Do you just guess? No, you got to legit go through the motions. And when you calculated this, what was the eccentricity of this guy? So what was it? 1.7 over 8.0. When you did the calculation, you got 213, 0. Oh my God. 213. That number is closest to which number? Mercury. You had to do the math. You cannot look at the pictures. Which planet has an orbit with an eccentricity most similar to the eccentricity of the moon's orbit around Earth? The moon has an eccentricity off the reference table of 0.055. Which one's closest to that? We happen to just write it right there. Saturn is basically the same. No homework. I think we need more practice with this before I have you do homework.